moving to Go. Take away.
Thank you. So, thank you to join us in this exciting and, well, this is the most important conference in Europe for open source, right? Everyone agrees with that. This is where we all collectively come here to learn a little bit, or maybe not learn that much, but at least share a lot of experiences around the things that we're working on or the things that we love the most. So this talk is a little bit about that. Not that I work too much with Go myself in this project that I'm going to present to you, but the rest of the companies trying or moving a lot for a lot of tools written on Go, and I'll try to explain you why and what kind of tools are we doing that. So this talk, if there's anyone here thinking about moving their source code of some application they have into Go, probably this will help you a little bit. Maybe not, I don't know. But that's the whole idea. So who am I? I'm Noberto. I'm a technical evangelist for MongoDB. You can see by the swag that I'm carrying on. So I generally do these things around explaining what we do with technology and how we can use MongoDB to help you guys figure out how to build applications. So this is a little bit of my gospel. I'm based out of Madrid, although I'm not Spanish. That's not a bad thing to be Spanish, but you know, I'm not. Just happen to live there. Yeah, that was the problem a little bit before. So let me see if I can fix that. Yeah. Okay. Better now, right? Okay. So, and I'm basically a gopher by choice because my background is mostly Java and Python. So Java, Python, C++, and all of that. But generally, Go does work very, very well. And I'm kind of falling in love with the gopher. They have pinky gophers as well, so never know what's going to happen there. So if you have any other questions, Twitter, it's always a good channel to chat. And obviously, my email address. So let's start by telling you guys what this talk is not about. Obviously, it's not about MGO. Do you guys know MGO here? Yeah? OK, so is anyone here using MongoDB to start with? Pretty much a big bunch of you. Everyone is using Go, I assume? Yeah. Or anyone trying to learn a little bit about Go, right? So you're in the right place. But I'm not going to talk about the Go internals or MGO, which is the driver. And obviously, I'm not going to talk about MongoDB as well. So I'm not going to tell you nothing about the feature set or how to set up a cluster or replica set or to do a query. I'm also not interested in talking about how to build applications of Go using MongoDB. That's not what it's about. It's about we as a company, as a project, let's say, we set up a set of tools that the database requires that are purely on Go. So I have mandated to do, guys, a little bit of introduction to MongoDB because there's a couple of people here that don't know what MongoDB is, right? So everyone heard about MongoDB, correct? We spam a lot, yeah? Who here likes or uses a lot of MongoDB? I've seen, OK. OK, so who here hates MongoDB? And that's fine because, as my colleague Asia Kamsky, I don't know if you guys know her, but she had a nice tweet about the database you hate the most is the one that you use. So if you hate a lot MongoDB, it means you're using it a lot, so it's all good. So keep on doing that. I'm going to talk to you about the components we've written on Go, which one of those there are, why, when, how, and the lessons we learned when we are porting a big chunk of C++ into Go. So a little bit of a short introduction to MongoDB. We are a database that wants to build this, so we want to create applications never before possible. That's the whole idea about MongoDB. This is a lot of marketing stuff. I work for marketing department since I'm a technical evangelist, so bear with me for a while. But this is basically the objective of MongoDB. It's not to have a MySQL database that works fine for everyone, or Postgres or Oracle or whatever we use, and then we're just going to flip it to MongoDB just because it's cool. A lot of people do that, and they are my friends, but generally that's probably not in your best interest. You need to think about what you want to do with your application and what are the limitations that the storage layer offers you. And if there are other options out there like Mongo, then probably you should have a look at it. But it's on this scope. It's things that you couldn't do before, and now you really actually want to do them. So it's an open source project, obviously. Otherwise, we wouldn't be allowed to be in FOSDEM. And it's a document-oriented generic or general purpose database, meaning that you could do a lot of stuff with it. There's a lot of use cases where MongoDB is pretty good, and there's a lot of other use cases that people tend to do good things with MongoDB as well. And this reflects in these numbers, which are more than 9 million downloads. And that number there, it's going to be essential for future slides in this talk. Hold on for that. But we have a lot of people signing up for our education platforms, signing up for the conferences on MongoDB, like MongoDB Days. And there's lots of people signing up for MUGs, which are MongoDB user groups. There's one here in Belgium. I know some of you, if you have been in that user group, they are spread all over the place, meaning everywhere, from north to south to east to west, everywhere. And there's a reason for that, is that, well, people don't just use Go. Go figure, right? So, shocking. There are lots of other technologies out there, especially languages, that use a database as well. So obviously, you're missing the most important of all, which is COBOL, right? Which is not there. There's a reason for that. We don't want to keep feeding the beast. But there's a lot of other applications out here that people build on top of these technologies. And MongoDB supports all of them, meaning that we have a library, which is basically a driver, that does all the heavy complication of communicating with the server, getting back the response, serializing things into VSON, and getting things done. Actually, sitting here, if anyone has complaints about PHP driver, the driver guy is here, Jeremy.
But not PHP.
Okay, but that's not, okay, so there you go. And it's one of the languages that we support. And there's also a lot of features about MongoDB that's, I'm not going to kill you with a lot of that, but I'll share the slides. And this is content available, so it's geospatial indexation, full text search, high availability, blah, blah, all those things. So looking at this picture and being at the Go dev room, there's something missing, right? So is this going to be recorded? So I shouldn't swear every time I use swag, but I'm doing it. Where the fuck is Go? It's not there. So what happened with Go? So how you have the guts to come here and talks about Go and you don't even have a driver? Actually, someone else has. I don't know if you guys know Gustavo Niemeyer. He's a well-known persona. He's been doing a lot of contributions to Go and to the Go ecosystem. He built a lot of stuff around Go, and the MGO is one of them. We as a company, we are users of what this guy has created, basically. Okay, so there's no better thing to see that we create this product or application, which is the database, and then other people build drivers that then some of us become employees of MongoDB, but also there's other people which in their spare time or just start building stuff. And Gustavo is one of them. He built the driver, and we use it. So it's very good. Our relationship is that we contribute to it. We do pull requests. We give him all the content that he needs to build it up and keep it updated. So trust the thing. It's very well built. It's actually one of our best drivers out there. So a database is usually not only a server. It also has a client and a set of tools that allow us to operate with it. Because, yeah, we have applications that use that, but you probably want to do operational stuff like migrating from data centers, importing data from one set to another set, building up new stuff, inspecting what is happening with your servers. All of those things need to be managed. And MongoDB is not different. if you download the targz from our mongodb.com/downloads, you will, if you unzip it, this is what you get, right? A binary folder with a lot of different binaries in it. And some of them, these ones, are written in Go from 3.0 onwards. Actually, 2.8 something onwards. But anyway, it's a different story. All of these have been rewritten into Go. So if you are installing MongoDB, you are installing Go, or binaries built in Go. So these are the tools we've rewritten. MongoDump, MongoRestore, import, export, BSON-dump, MongoStat, MongoTop, MongoUplog, MongoFiles. From the guys that actually use MongoDB, is this new to you guys, or you know about it? You know about it, right? And how is the performance of it at this point? Is it good? Is it practical? Well, they are command line tools, so you do normal operations with it. But some of these tools are very, very important because they do data loading or laid offloading from systems. And if you have a 10 terabyte data and you start doing a dump, you want that thing to be fast. And you want it to be, multi-threaded and all that, so that you don't stay a long time on it. So there's a need to do something about that in terms of performance. But we also have a lot of other tools, or let's say applications, that also are completely built in Go. MCI, it's probably the first big project we have internally that completely uses Go. Actually, the damn thing is completely on Go, except for the front-end layer, which is Angular. I'm not going to talk too much about it because we are going to do something quite nice in a couple of months about it, so stay tuned for it. And the MMS agent. Here, anyone knows what MMS is? Some of you? Okay. I'll talk to you a little bit about it. So MCI is basically Mongo Continuous Integration Tool. We use all the tools like you guys do, like Jenkins, Bamboo, all that. And all of those are great, right? Everyone likes Jenkins. Yeah? Or Hudson, as it was previously called. Yeah? In Bamboo. Do you guys know what Bamboo is? Okay. And it's great, right? So why do we need a new tool? Well, if we think about it in the database world, databases are particular applications that need a lot of integration. There's different versions, that there are several different builds, there are several different builds with different extensions on it, and we kind of broke Jenkins a lot. So we decided to build something probably a little bit more dedicated that uses MongoDB, uses Go, and it works fine for us now. So it's pretty cool. We also have MMS, which basically MMS is MongoDB management system, which allow you to do a whole set of things like automation of a cluster. I have an idea of a cluster that I want to build. I have a set of machines, and I want the system to build it for myself. I don't want to go to each one of those machines and configure them and set it up and put the replication on it. No, I don't want to do any of that. I just want the system to do it. So MMS is the solution for that. We do that. We also do the monitoring part and the backup, completely automated backup of your cluster, which for ops guys, this is kind of cool. And the MMS agent used to be written in Python. And we had the backup agent, which is a separate agent, which used to be written in Java. Does anyone know what's the big problem of doing that? A tool that goes into servers and picks up things and manipulates data in servers that are behind firewalls and behind firewalls and behind firewalls. Do you guys know what the problem is? Has anyone dealt with that? How many of those servers do you think are configured with Java? Very few, I can guarantee you, especially on very traditional, very archaic environments like big banks and super secret organizations. They don't do Java. Or if they do Java 1.4. And this is the reality. People do not put in a JVM just because they like. They will probably use the same ISO that some guy back in the 80s built once, and that's it. That's the one that they will use. For Python, exactly the same thing. If a server is running a database, they do not conceive the need for having Python libraries on it. So probably you're going to end up with a lot of problems of you saying to the people, yeah, we have this great tool that monitors and backs up and deploys everything automatically, but then the thing doesn't run because they do not allow it to integrate. So we needed to, for the MMS agent, we needed to come up with a solution. A solution that would be basically these things. We want to create an ID of the cluster, create it in a JSON file, send it to the machines that are being monitored and managed, and then they will create themselves. And it needed to be reactive. It needed to be synchronizing with all the remaining nodes, so you need to have a good parallelization engine to make sure that it knows what happens around itself. And it needed to be extremely cross-platform, reactive, and complete. You need to be able to do everything that we do in MongoDB, configure all the features, and make sure that the thing runs. So these are the, let's say, primitives for the MMS agent. MongoDB tools, they are a little bit different because they run the command line, and they basically used mostly these four. Mongo export, Mongo import, which basically uses text files. You just dump things into text, like CSV, TSV, whatever, and then you import it back. This is pretty good for analysis of your code or your data. If you want to export it to a Excel spreadsheet or whatever, you usually use these tools. Mongo dump and Mongo export is when you want to build your own backup stuff. So you have your own backup processes that dump data somewhere in the tape or somewhere in your network attached system. You use something like this if you don't want MMS, obviously. And there's also monitoring tools or measurement tools like MongoStat. MongoStat is a tool that we have to have a look of the cluster. How many inserts per second, how many queries. So everyone here is familiar with IOStat and VMstat, correct? So think about MongoStat as the equivalent for MongoDB. You can monitor everything in real time or giving it a unit of time to do the sampling. It will just collect data statistics on it. We also have MongoTop. You guys are familiar with MySQL Top, for example? Everyone knows what it is? Well, basically gives you how much time you are spending on one of these operations. MongoTop just does it per namespace, which is basically how much time we are spending for writing and reading on the separate databases and collections. So these are the basic tools that we migrated to Go. And why would we do that? They were working. They were in C++. Everyone loves C++, right? We have a big bunch of engineers that work on C++. Why the heck do we need another tool or another language? First of all, when we started building the project, there was limited resources in terms of people. We had hardcore, and we still have hardcore C++ people, and we're a very short team. So what we did is we need to create all these tools, especially Mongo export and dump, but we didn't have a lot of time, and we had a big code base. So basically what we did is extend what we have in terms of source code and do those tools. So basically we created a lot of these tools with dependencies to what the kernel already has. Now, if you go to 2.6 and unzip it, some of the tools are almost the same size as the MongoD. So basically we were shipping MongoDs on certain of those tools. And there's a good reason for that. There was a lot of dependencies, like you can see from this graph, that call other dependencies and then call other dependencies. And breaking those is quite hard in C++. Has anyone done some kind of action of extrapolating code from C++ hard base and making an isolated tool? It is hard. It's not as funny as you might think it is. So there was a lot of legacy code that we needed to support, and this was basically creating a lot of constraints when we wanted to add new features or change the behavior of features, like adding multi-threading, for example, to certain parts of those tools. And parallelized processing was one of them. I don't know how many of you guys have experience with C++, but it's not that it's not possible, it's just hard to do multi-threaded development on a single-threaded, changing from a single-threaded to multi-threaded when you have already established code base. It's really hard to do it in C++. Probably Go, it's funnier and much, much faster. And obviously portability. So Who here does C++? Bless you. So what happens when we need to build things for different kernels or different versions of the operating system? What's the first thing we start to type? Well, I can tell you one thing. It's an if-def for preprocessor instructions, right? If that's a system based on Windows, we're going to load certain libraries, I'm going to do things differently, and then other things. Testing that, it might be hard. You need to have all your environment already pre-prepared. You have to launch ISOs. You have to launch the server there. You need to run the same tests over and over and again on all these distributions. So you have to be prepared for that. So the why that we would do such a migration were a couple of things. We decided to change the code base of these tools because we wanted to test them better. We wanted to have a much more modern code base to support it. We also wanted to make use of all the let's say knowledge that we acquired building internal tools that like the MCI. So we were prepared to just do the shift. We also have a lot of good Java developers in the house, like MMS. It's mostly Java. So we were kind of, what are we going to decide? Are we going to build these new tools in Java or some other thing? Well, thank God the restrictions on running compiled code on environments that don't have JVMs, that would need to be solved. So go solve that very, very easily. So portability was a very, very important thing. And obviously, we are also already doing that same code change for the MMS, so kind of handy. So we needed to also separate ourselves from the development and the cycles of development from the kernel. So if MongoDB 3.0, which is about to be launched, takes like 6 months to build, if the tools team needs to wait for something to change somewhere deep nested on the kernel, that creates a lot of lag between what we want and what we can achieve, right? So, and this was creating a lot of problems when we wanted to bug fix it, correct it, improve it, and so on. So that was a big issue as well. So to separate us alongside from the kernel team, those guys are slow, we are faster, so how are we going to deal with that? And there was immediate things that we've seen that resulted in big improvements. So first of all, we could immediately add multi-threading support on it. It's not that we cannot do it, and it's not that we don't do it in MongoDB. Yes, we have some multi-threaded parts in MongoDB, don't worry. It's a database level locking, but that's not the full thing of it. But we needed to do this immediately, and we need to do this in a very easy way, and Go does that. Go does that like piece of cake. It's really one of the best things ever. I don't know who came up with ideas of Go routines, but it needs a kiss really every day. So we also needed to do some stuff more intelligently, like scheduling to avoid logs. We have granular level locking for MongoDB for 3.0, so we probably would like to benefit from it. We also wanted to have something called bulk inserts and so on that we have implemented on the wire protocol. So we need all of that. And the immediate trade-off is that we had better performance in a large scale. So this arrow over here is running the 2.6 MongoDB importer. And this is running with the new one, the new tool, so 3.0, with just basically adding it up new threads. The above one doesn't have multi-threading, so if you have like 1 terabyte in one collection and 10 gigs in another collection, you want to export all of that, you need to wait for that 1 terabyte to complete, and then you will go to that smaller thing that you probably don't need so much time to waste. Now we can do it very, very easily. And the performance gain is like quite significant. So how do we do it? Obviously, doing something fresh makes us all very happy, right? It's like sweeping the dust under the rug. You just can start new. So you start fresh. You know how you built it before. So you pretty much know what you need to be doing next. That's cool. So we rebuilt completely the tools, a new complete code base. We needed to maintain, obviously, compatibility with the other versions of the server. MongoDB does that sorry, the mgo does that very, very well. So that would not be a problem for that. And the way that we deal with things like the BSON versions and so on, since BSON is a binary format, you don't really need to care too much about it. As long as the library that implements it and serializes does it well, done. That wouldn't be a big problem. Go has this thing called GoC or CGO or CGO, depending on where you're coming from. So, which gives you a very, very nice C bindings. If we actually needed to call something from the from our legacy code, we would just call it. Just import C, build a small C wrapper, call the function, and that's it. And that is very, very cool. And the multi-threading, again, it's like it's fantastic. It's a primitive of the language. If you have something that you're running single-threaded, changing that to multi-threaded is just calling Go routine, and that's it. And it's pretty much what you need to know for this kind of migrations. So it all made us very, very happy. And obviously, we didn't need to deal with C++ anymore that much. So we had an happier team. And also, using a modern language, which is built for what we have today, gives us a set of much better parsing libraries. So parsing command line arguments on C++ is completely possible. Everyone likes it. Well, no. Basically, no one likes it. But it's obviously there. With these new parsing libraries, it was much, much, much easier. And yes, CGO is super, super handy. Let me just get out and show you guys some code instead of talking so much. So when I say that bindings of C are very, very easy, by the way, this is Sublime. I'm not happy to show you code in Sublime, but it's much more interactive. Vim rules, right? Everyone knows that. So you just import C, and you call C with the function that happens to be in a file in the same directory that we're importing it from, and you can call it from Go, and that's it. That's pretty much as much effort as you need to think about when you are implementing things with Go and you need to do some kind of binding. Yesterday on the Ruby talk, there was a colleague of mine, Emily, which was talking about how hard it was for Ruby to implement because she had to do all the mappings of objects to C and C to Ruby and Ruby to whatever. So this, I mean, this is beautiful. And there's a lot of other places that we call this. And by the way, if you see a lot of MongoDB staff doing C binding talks, they are all because of one single feature, which is SSL and Kerberos support that no one uses, obviously. And the C parts that you are calling, that's it. So anyone can write things like this. And it's like, damn. So the previous talk, we were talking about gclib or whatever. And why would we use it from Go? It's just, you know, go use CGO and you have it. It's pretty much what you need. So yeah, go fetch it. It's obviously on golang to dark. It's super, super handy. And the code snippets that if you go to the MongoDB repository for the tools, this is the thing that we've done. All right. So we have also nicer parsing libs. I'm going to show you. This is C++ code that you guys can't see. And I'll show it to you guys in the code because it's much easier. So if you go to options.go, which is the libraries that parse all the internal arguments that we use from the tools, obviously we have a common thread of where we treat all the common arguments, and it's like simple as defining structures which have options on it, like db.collection and .general if you want help or version or verbosity. So and this is quite nice. Everyone can read this very, very well, right? And this to implement and test, it's also very, very, very fun to do. And you just need to create structures for the things that you need, like SSL or wherever. When you're dealing with the same thing supported by C++, you start with a big license agreement, because this is also one of the good things about Go. The fact that we moved away from the C++ code base, which is bounded to the kernel, and moved it to a separate code base, also allowed it to change the license of it. So every time you do contribution to MongoDB, you need to go and sign the agreement of the license as a user and all that, because of the Affero licensing. If you change that to Apache, it's much, much simpler. You can just accept commits and pull requests with no problem. But getting back to a little bit to the tools, this is the kind of things that you need to start adding to the system just to parse command line arguments, which is not as bad. But if you think about all the heady work that you need to do with the if-defs again for specific stuff on Windows and specific stuff just to see if Mongo SSL is implemented or not and all that thing, well, it kind of comes quite heavy. And yet, you need to add up the second part of it, which, let me see if I can make it happen, which is the .h, which everyone loves, which is a useless piece of code that we cannot miss, because if we miss something here, it screws up completely our compilation. So, okay, enough batching on C++. We all love C++ anyway. And obviously, Go routines. Making this function over here Go multi-threaded, it's just calling it as a function, as a Go routine. And that's it. And this is why the guy that invented it needs a kiss every day, because it makes life so much easier. But not all this process goes without, its bumps in the road. You have to do a lot of things, because although Go is 4.5, 5 years almost, it's still there's an ecosystem that needs to be built, or there's still a lot of stuff that it's not yet completely ported to Go, or at least the parts that have been either are very simplistic or do not have the full feature set of all the things that we need. So for example, we needed to, even though we have access to SSL and Kerberos libraries externally, the support on it, or the way they were implemented, there were a lot of bugs, so we needed to fix them, which also helped us to contribute back to the Go ecosystem, which is cool. So we needed to fix a lot of that. The support from getting the documentation for all of these things, it's not as easy as one would like, although the guys that done it very, very well, hopefully. But still, there's a lot of learning and a lot of scratching and a lot of thinking about how things are built on Go, which are some libraries that you cannot fully trust on, so you need to scramble a lot with that. And obviously, the driver, although the driver is very good, especially coming from especially being in a completely third-party driver for us, so it's Gustavo's work, basically, and a couple of contributors. The way that we work with drivers, it's a little bit different from the way that MGO is implemented. So integrating gelling all this together, the way that we work with things and the way that it's implemented in MGO, also is a little bit of a challenge. So we needed to also be at the mercy of the driver bulk support, for example, which didn't really exist or didn't work as good as we would like it to be. So this ends up being a lot of contributions, especially from Mike O'Brien, which is the head of the Go tools, to contribute a lot of things back. So takeaways. What have we learned and what have we achieved? We achieved a better code base. Much better to isolate it from the kernel, so the guys from the kernel can do their stuff, and the guys from the MongoDB tools can do their own stuff. It's wider testing, so it's better tested today than before, because we don't have to build unit tests in C++, for example, and we can just test once, and we'll run exactly the same thing on all different platforms, which is all about portability. So before, we needed to create specific tests for Windows, and we still have to do it for specific functionality like SSL support and all, but in essence, the generic way that the Go tools work is that you test it once and it just runs everywhere the same way. So that's guaranteed. That gives us a lot more room to do other stuff, which is much more interesting. Less fear as well of we as Go team tools, requiring some functionality or some change on the code base for the C++ stuff and breaking the kernel. That never happened. Okay? If you ever seen that, something being introduced by some other thing that is not relevant enough and breaking some kind of critical feature at MongoDB, that never happened. Don't worry about that. But it could happen, so we want to avoid that. Obviously, it allows us to do talks on Go and expand our GoFu, which is good, and we won't let. But also allows us to get in touch better with the tools and with the community, and we can get back a lot more pull requests and a lot more contributions and give back a little bit. So there you go. We are expanding our GoFu. Obviously, we gain a lot more performance. Not that we couldn't allow it to do multi-threading and all just on Go, but the fact that we can iterate much faster on a simpler code base and a much more modern makes us all more productive at the end. Better portability, not so many tests, not so many hangs around. You know, I need to set up a full environment just to test this. I just can run it from code. And a happier team. That's quite important, because those guys pay beers and I go to their parties sometimes, so it's pretty important. And obviously, yes, we help up with some contributions for OpenSSL wrapper, Go driver, and the parsing libs and so on. So it's good. And the one that I brag a little bit more about is that from those 9 million downloads, if everyone updates their version of MongoDB, we will probably be the biggest distribution based on Go, or at least part of it. So we will be sending Go code to a lot more people than ever before. So it's pretty good. I asked yesterday, Brad, what was the biggest distribution of, let's say, end user Go functionality or binaries. There's something going on the Go drive that you install and all, but it's not clear if it's using Go or not. So hey, we're probably the biggest one. So I'm excited about this, okay? I obviously can't wait to get my hands on this code and test it and break it and complain about it. It's great. So can I start using it? Obviously I can. 3.0 release candidate 7 is already out the door. It has a lot of new features, like a pluggable storage engine, improved concurrency, compression, large replica sets, and obviously our tools rewrite. And it's also coming with the WireTiger, which is making big data roar. So MongoDB will make big data roar. And do we guys have any questions?
Part that you showed the options.go, I assume that's the argument parser, right?
Yes. So the question is, on the code that you shown, you stupid asshole, was that the argument parser? Yes, it is.
Yes, but you didn't use the standard flag.
No, we did not use the standard flag. Good question. I don't know the answer for that one. I think that the other one is much cooler, and we can contribute to that. So, but that's the reason why. I'll let you know. Just drop me an.
Command line compatibility with the previous tools?
So yes.
Because if you are, that's probably why.
Yes, and probably that. There you go. But not all of them. So there are a couple of command line arguments that we are dropping because it will not be compatible with the way that we export the data on 2.6 to 3.0. For example, there was a cool feature, in my opinion, that you could export data from a MongoDB instance without the instance being running. You just pointed to the DB path. Since we now have different storage engines, meaning that not everything is going to be stored in bson purely, we cannot do that anymore. And also, we cannot do that anymore because we changed the way that we do with files. So, but that's a completely different talk. I can show you some slides of that, but it's not the purpose of this one. Any other question?
Just on that one.
Yep.
You have command line arguments beginning with double dashes, correct?
The question is, do you have command line argument beginning with double dashes? Yes, we do. That's the answer to your question. There you go. Any other question? So I'm entitled to a goofer.
Thank you very much.